Skeletal muscles are attached to bones by tendons. Each skeletal muscle in your body is made up of bundles of muscle fibers. Muscle fibers are specialized cells. They contain multiple nuclei and are made up of myofibrils. The stripy appearance of the fibers results from the regular arrangement of the myofilaments within the myofibrils. In the myofibril arrangement, the sarcomere is one of the segments into which a fibril of muscle is divided. The M-line provides an attachment for myosin filaments. The Z-line provides an attachment for actin filaments. The A-band is the darker band of the myofibril containing the myosin filaments. The H-band is the lighter section in the middle of the A-band, where only myosin is present. The I-band is the lighter band of the myofibril containing only the actin filaments. When the muscle is relaxed, the protein tropomyosin blocks the myosin binding site on actin. Muscle contraction occurs when the muscle receives an impulse from a nerve cell in the form of an action potential. The impulse penetrates to the center of the muscle fiber via transverse tubules, deep infoldings of the sarcolemma. This causes calcium ion channels in the sarcoplasmic reticulum membranes to open. Calcium ions diffuse out rapidly into the myofibrils to bind to the troponin molecules. The troponin molecules change shape, causing the tropomyosin to move to a different position on the actin filaments. The myosin binding site on actin is now free, and the extended myosin heads bind to actin. The bound ADP and phosphate are released, causing the myosin heads to change back to their relaxed shape, so pulling the actin filaments towards the center of the sarcomere. The binding of another ATP to each myosin head causes them to let go of the actin. Each myosin head acts as an ATPase. The breakdown of the ATP to ADP and phosphate in the myosin heads releases energy which extends the head once again. During muscle contraction, the actin and myosin filaments do not shorten, but they slide past each other. If calcium is still present, and there is still a supply of ATP, this process will repeat again and again. After the action potential is passed, the calcium ion channels close and the calcium ions are pumped back into the sarcoplasmic reticulum. This allows the troponin to return to its previous state and causes the muscle to relax.